Imagine the ground beneath your feet suddenly trembling, shifting, shaking. This is the power of an earthquake, a phenomenon that has been shaking the world quite literally for as long as the Earth has existed. But what exactly is an earthquake? An earthquake, in the simplest terms, is a sudden and violent shaking of the ground. Often it's likened to the energy released when you snap your fingers, but on a colossal planetary scale. This energy causes the Earth to tremble, often with a force strong enough to topple buildings and crack open the land itself. But where does this energy come from? The answer lies beneath our feet, in the very crust of our planet. Earth's crust is not a single solid shell. It's more like a jigsaw puzzle composed of large pieces called tectonic plates. These plates are constantly moving, albeit at a pace slower than a snail's race. They slide past each other, pull apart, or crash together. Most of the time, these plates move smoothly, but sometimes they get stuck at their edges due to friction. When the stress on the edge overcomes the friction, there is an earthquake that releases energy in waves that travel through the Earth's crust and cause the shaking that we feel. And just like that, the solid ground beneath us becomes a rippling wave, a testament to the immense power that lies beneath the surface. Each earthquake is a reminder of the dynamic nature of our planet, a planet that is constantly changing, evolving, and reshaping itself. But what about the biggest quakes, the ones that leave destruction in their wake? These are usually the result of major shifts in the Earth's crust, a release of pent-up stress that has been building for years, even centuries. So in essence, earthquakes are the Earth's natural way of releasing stress. They are a fascinating, if sometimes terrifying, part of living on this dynamic planet we call home. But did you know not all earthquakes are created equal? Just as the diversity of life on Earth is vast, so too is the diversity of earthquakes. Each one has its unique characteristics, origins, and impacts, making the study of earthquakes a truly fascinating endeavor. Let's start with fault-slip earthquakes, the most common type. These occur when tectonic plates, the colossal jigsaw pieces that make up the Earth's crust, slide past each other. Sometimes they get stuck at their edges due to friction. When the stress on the edge overcomes the friction, there is an earthquake that releases energy in the form of waves that travel through the Earth's crust and cause the shaking that we feel. Then there are volcanic earthquakes, which are directly related to volcanic activity. These tremors are caused by the movement of magma beneath the Earth's surface. When this molten rock forces its way to the surface, it causes the surrounding rocks to crack and fracture, resulting in an earthquake. So if you're near a volcano and you feel the ground shake, it might be a sign that the volcano is about to erupt. Lastly, we have collapse earthquakes, a less common but equally intriguing type. These occur when caverns or similar underground structures cave in, causing the ground above to collapse. These quakes are often triggered by human activities, such as mining, that create voids beneath the surface. They may not be as powerful as their tectonic and volcanic counterparts, but their impacts can be devastating for those directly above. From the depths of volcanoes to the shifting of tectonic plates, the origin of an earthquake can vary greatly. Each type provides us with unique insights into the inner workings of our planet. By understanding these seismic diversities, we can better predict their occurrences, mitigate their impacts, and continue to navigate the ever-shaking ground beneath our feet. When an earthquake strikes, it sends out various types of seismic waves. These waves are the unseen force that makes the ground shake and tremble beneath our feet. They're categorized into two main types: body waves and surface waves. Body waves are the first to be detected once an earthquake occurs. They're like the heralds of the coming quake, announcing its arrival before the main event. There are two types of body waves: P waves and S waves. P waves, or primary waves, are the fastest. They travel through the Earth's interior, compressing and expanding the ground in their path, much like a slinky. Following closely behind are the S waves, or secondary waves. They move slower than P waves, but are more destructive, shaking the ground back and forth perpendicularly to their direction of travel. But it's the surface waves that are often the real game changers. These waves travel along the Earth's surface, and they're the ones responsible for the most significant ground shaking. Surface waves come in two types: love waves and Rayleigh waves. Love waves move the ground from side to side, causing horizontal shearing and shaking buildings violently. Rayleigh waves, on the other hand, roll along the ground just like waves roll across a lake or an ocean. They shake the ground up and down and side to side in the same direction that the wave is moving, making them the most destructive of all seismic waves. So when you feel the ground trembling beneath your feet during an earthquake, what you're really experiencing are these seismic waves in action. The initial, less destructive shaking is due to the body waves traveling beneath the Earth's surface. The later, more violent shaking is caused by the surface waves rolling across the Earth's crust. In essence, earthquakes are a symphony of these seismic waves, each playing their part in shaking the Earth. Understanding these waves and how they behave can help us better prepare for and mitigate the effects of earthquakes. While body waves shake the Earth's interior, surface waves make the ground tremble beneath our feet. In the world of seismic waves, there are places known as shadow zones. These regions, intriguingly quiet amidst the Earth's constant hum, remain undisturbed by certain types of seismic waves. Picture the Earth as an apple. If you were to take a bite, the shadow zone would be the area untouched by your teeth. This enigmatic silence stems from the Earth's outer core, a swirling sea of molten iron and nickel. When seismic waves from an earthquake attempt to traverse this liquid layer, they are refracted or bent, and some are absorbed altogether. But why are these seismic silences so significant? Well, by studying the areas where waves don't reach, scientists can gain precious insights into the Earth's internal structure and composition. The shadow zones act as a sort of natural radar, helping us to map the unseen depths of our world. The shadow zone, therefore, is not just a silent region, but a window into the core of our planet. Despite their destructive power, it is possible to live with and prepare for earthquakes. Key to this is understanding the risks and taking proactive steps. Regularly conducting earthquake drills, for instance, can ensure everyone knows what to do when the ground begins to shake. Building earthquake-resistant structures is another significant measure. By incorporating flexible materials and innovative designs, we can create buildings that withstand seismic forces. But it's not just about physical structures. It's also about building resilient communities. This means having emergency plans in place, knowing where to go, what to do, and how to communicate when disaster strikes. It's about creating systems that can absorb the shock of an earthquake, recover quickly, and adapt to prevent future damage. In earthquake-prone regions, this resilience is crucial. It's a testament to human ingenuity and adaptability in the face of nature's power. With knowledge and preparation, we can reduce the impact of earthquakes on our lives. Earthquakes are not just natural disasters, but reminders of our planet's dynamic nature. By meticulously studying these seismic events, we gain invaluable insights into Earth's past, present, and future. Each tremor, each rumble tells a story of shifting tectonic plates, of mountains rising, and of landscapes transforming. But it's not just about understanding Earth's history, it's about shaping our future. With technological advancements, we are getting better at predicting earthquakes, giving us precious time to brace ourselves for their impact. Sophisticated seismic sensors, high-speed communication networks, and advanced analytical models are all part of this crucial endeavor. Moreover, international collaboration plays a pivotal role in this journey. By sharing data and expertise, countries can help each other mitigate risks and save lives. As we continue to learn from earthquakes, we can better prepare for the future and respect the awesome power of our planet.